Hi everyone, and thank you so much for coming. Today we're going to be talking about 4 questions to ask your dev team.
Talk to developers? Why would I want to do that?
Developers are awful. They're always complaining that our work takes too long.
They don't care about production anyway.
And when they ask for new services, they always get it wrong and waste so much of our time.
And they think that anyone can log into AWS and just do it themselves.
Today, we're going to be talking about how to improve communication between development teams and platform teams, because in our experience, these teams don't talk enough and not about the right things.
We'll be taking the role of the platform team because this is what we know best. But that doesn't let any of you developers off the hook. You can also start this conversation.
I'm Hannah Foxwell.
And I'm Jérôme Wiedemann, and we're both Associate Directors for Pivotal Labs Platform Services in EMEA.
That's right, we do the same job, dream team. Between us, we look after all of Pivotal's customers in EMEA. Our mission as a team is to create wildly successful platform teams for our customers.
Technology is actually the easy part. It's the people problems that are the most difficult part of what we do. And for those in the front rows, you will be able to see that I lost some hairs in the process compared to the picture on the screen.
And I have a bit of a fatter lip after getting smacked in the face by the pavement last night. Not sure how I'm going to do with moving my face and talking, but I'm going to try. So we've got a lot to cover today, so I'm going to jump right in with question 1. How are we going to work together? Whilst we want teams to be as autonomous and independent as possible, we rarely deliver any value in isolation. Good fences make good neighbours. Knowing who does what helps us deliver value together. There are many ways to organise your teams, but this is a pattern that we've seen has been successful in many of the organisations we work with. The application teams deliver apps and services for end users. They build it and they support it. The platform team provide a platform service for those application teams. They build it and they support it. And then there's usually an infrastructure team too. They provide infrastructure as a service to the platform team and possibly other teams too. They build it and they support it. You'll notice that the team missions are all the same. Everyone wants to build an amazing product and a valuable service for their users. The users of the IaaS team is probably the application and platform people. The users of the platform are the application developers. Some other patterns that we've seen work include the separation of dev and ops, where segregation of duties is a requirement. You only do this if you absolutely have to in a regulated environment, but you want to avoid creating knowledge silos. You need to make sure you're communicating and collaborating to make this model work. We've also seen additional tools teams supporting both the application and platform teams with things like CI/CD and monitoring. Too much centralization can become a constraint, but actually providing self-service tools helps your developers focus on what's important instead of having to manage it themselves. We also have seen recently SRE teams being established within organizations following the Google SRE model. We actually think that SRE practices are something that any team can implement, but we've also seen this organizational model work. But the question was, how do we work together, not how do we organize ourselves? The developers you support are never satisfied. They just keep asking for more. We need to embrace change. Our end users' needs will change. The applications will change. New applications will replace old, and the technology that we support day to day will change. So your developers' needs will change, and that's to be expected. This is why we don't believe that building a platform is a project. It's a product. Think of the application developers as your customers. So we all are familiar with the role of a product manager within an application delivery team. The product manager is going to be talking to their end users, finding out what they need, figuring out what features the team need to build, and prioritizing a backlog of features for the application team. That's exactly the same as a platform product manager. The platform product manager is going to be talking to their users, who are the application developers, and they're going to be figuring out which features the platform needs to support and prioritizing those features for the platform engineers to work on. As the end users of the applications needs change over time, so will the application developers' needs of the platform, and that's to be expected.
So I'm going to tell you a story. I used to work for a French legacy company was some years ago before joining Pivotal. Actually, this company wanted to build its own private cloud. And well, they've contacted a bunch of software vendors, very expensive software vendors, and they've put everything together, try to build the private cloud. But this private cloud was built on the fact that the specifications were already done beforehand. So no one was ever interviewed, especially not the users. So it took them 2 years to build this private cloud. The cost was around 10 millions, and they expected to have 1,000 VMs running after 1 year. So this, well, didn't happen, right? And they had only 50 VMs after 1 year, which is not great for 7 million invested. So they've just shut down the whole platform and they trashed it, and they lost 10 millions in the process, and also some people. So the question too is, what is your path to production and how can I make it easier? So many organizations I've worked with have evolved processes over time that makes the path to production difficult and painful for application teams. We want to help solve that problem. Josh Long, a Spring advocate, says, production is the happiest place on earth. And I agree with him. Production is actually the only place where value gets delivered to users, and it's the only place where it's possible to collect useful data and feedback to continuously improve the service. You will want to get as fast as possible from idea to this idea running in production to deliver value. So why are we scared of that production? A lot of organizations are scared of changes in production because it can break. But what makes a system a system? It's change, right? We're not going to be talking about the usual ETL and change management process here. We're going to talk about trusting and giving your teams the freedom to go to production whenever they feel it should be the case, by introducing sane practices and proper checkpoints.
And we've definitely seen some insane practices and processes in some of the organizations we've both worked with over the years.
A lot, too much. So the DORAS report, it's actually, DORAS stands for DevOps Research and Assessment. It's a company who was bought by Google some time ago. So this report tells us that there are 4 metrics measuring the delivery performance. The DORA reports, so those 4 metrics actually are deployment frequency. So this is how often you deploy changes to your services and make them available to your end users. The second metric is lead time for change. This is how much time you need to go from code committed to the same code running in production. The third one is time to restore service. So this is how much time is required to restore service when an incident impacting end users occurs. And the last one is change failure rates. This is how much change lead to a service outage. So you will want to target low value for each aspect to be able to deliver value faster to your customers and keep them happy. Try to see where you fit into this table and let us know after the talk. One way to help you is to bring automation. So automation helps you free up time by reducing toil. Time that you can then reinvest to create and deliver value to your users. Basically, you just want to automate yourself out of the job. Otherwise, manual work will only increase over time while your service is scaling up. If your team is split between dev and ops, and as Anna said, you should carefully consider that option, ops should feed back the pain points to the devs so that it can be addressed through proper automation. No one wants to do 100 times the same actions every day. You don't want to have all your tests done at the end. You want to fail fast. Test-driven development is another way to build confidence and trust that a change is not going to break something else. TDD is about writing the test before the code, and then write the code that will make the test becomes green. You might want to introduce tests at every step in your path to production. So in the application code, unit tests, integration tests, user tests. In the platform deployment automation tooling, also you will want to introduce testing. And security teams could also provide a comprehensive test suite to ensure your apps and your platforms follow the security guidelines of your company. That's often forgotten and will really help you over time. Remember, we want to go faster, so all those tests should be part of the automation tooling in place. Another tool which helps with change is the feature toggle. Feature toggles allow to release features to users separately to code deployment, and it massively facilitates rollback in case a problem occurs. Just switch the feature off and you're back on track. This can also help with releasing a feature to a subset of users and build confidence before releasing it globally.
So, we've unblocked the path to production. Now we need to support our service in production. So question 3 is, what level of reliability do our users need? We want to make sure that we're clear about the end user's expectations, and to do that, we need to talk to the people who know the user best. Talk to the application delivery teams. If your application is unavailable, your users will be unhappy. It doesn't matter if you're delivering amazing features, if your service is unavailable half the time, or it's too slow to use. Reliability is fundamental to any product. If your application is unavailable, your users will be unhappy. That means that if your platform is unavailable, and that results in your application being unavailable, guess what? Your users will be unhappy. And if your infrastructure goes down and it takes down your platform and your application, then the users of that application, they're going to be unhappy. This is why reliability is something that we have to deliver together. Rarely can one team in isolation take responsibility for this. Reliability is a team sport, and we need to talk about it. So while we're talking about reliability, let's go through some of the ways in which we measure this. Let's talk about service level indicators, service level objectives, and error budgets, and how these actually work across teams. A service level indicator is a metric. It should be an unambiguous measure of whether your users' needs are being met. We recommend black box monitoring or synthetic monitoring to replicate user interactions with the product. An SLO is a threshold, and it's often described as a percentage in terms of a number of nines. For example, 4 nines would be 99.99%. Your SLO is never 100%. There's always a small amount of expected and tolerable failure, even if it's very, very, very small indeed. Not even your internet service provider can provide 100% availability. That means that if the user's accessing your product over the internet, they're never going to experience 100% availability. So why should you try? As a platform team, it's also a good idea to set SLIs and SLOs for pre-production environments, which seems counterintuitive, but are developers able to push code to pre-production? That's a great question to ask. I guarantee you, if you start a conversation with your development team and you show them that you care about their ability to work and their productivity, that's going to be a really positive conversation. Your error budget is the inverse of your SLO. So your error budget is that small amount of acceptable failure within your system. Time isn't the only way to measure your error budget, but it's an easy thing to reason about, especially when you're talking about error budgets across teams. Everyone understands the concept of time. So, for example, if you wanted an SLO of 4 nines, 99.99%, that means you have an error budget of just 4 minutes. Whereas, actually, if you will go a bit lower, if you want to support 3 nines of availability, 99.9%, you have 40 minutes of error budget over a 28-day window. So if your end user expects 99.9% availability, for example, who gets to use those 40 minutes of error budget? If the platform team used the whole error budget, that doesn't leave anything left for application teams to push new code. It doesn't leave anything left for the infrastructure team. That doesn't sound very fair. Again, reliability needs to be a team sport. We need to have a conversation about this and agree our SLOs together. So as an example, we have an application and we've established that the user requires 99.9% of availability. That gives them an error budget of 40 minutes. The platform and the infrastructure teams must provide a higher level of availability. Otherwise, the application can never meet its SLO, or will constrain the amount of change that the application teams can ship, inhibiting their ability to innovate and make changes. Remember that your end user doesn't care which team took down the service, only that the service was down. You need to agree an error budget policy before you need one, before you've exceeded your error budget. You need to have a conversation about SLOs before it becomes a problem. And you need to agree what's going to happen when some of your error budget gets used up. So here's an example of an error budget policy. If your service is performing within its SLO, then all teams are free to make changes within the normal release process. But what if one team has exceeded their error budget? You actually might want to reduce any risky activities or deployments that would impact users further. That includes all teams who provide services in support of that end user experience, the platform team and the infrastructure teams, for example. This is something that you need to write down and document and agree together. It can't be done in isolation.
So things will go wrong, and proper incident management is going to help reduce downtime, improve reliability, and make your team happy about it. So what are we going to do when things go wrong, actually? As Hannah said, 100% availability is not the right expectation. Apart from pacemakers, well, you don't want them to fail. And anti-blocking systems also. You don't want to crash into a wall. It's the nature of building complex systems. Failure happens. If your availability is too high, developer will just tend to think that it's the new normal. In this case, you should, on your own, inject failure in your system so that developers keep building resilient applications. Only actionable alerts should trigger incident response. That's a rule. This obviously comes with proper monitoring in place. If your system is automated enough, like it is the case with Bosch or maybe Kubernetes, for example, then only problems impacting your users should trigger incident response. Alerts shouldn't be sent to everyone for everything, and alerts should only be sent for problems which require immediate actions or because it impacts your end users. You should carefully consider what kind of alerts you want to trigger a response from. So there is no need to wake one of your engineers because there is a payment processing error in one of your apps, but instead wake him up if there is a significant drop in payment processing rates. Divergence from a baseline is usually a good sign that something is going wrong. A lot of problems can have also automatic remediation in place, which circles back to the value of automation we spoke about earlier. We want also to replicate user interactions. A way to do that is by using black box or synthetic monitoring from outside of your system. In this way, you get a view of what is happening from the perspective of your users. On top of that, canary applications tell you quickly if the problem is related to the platform or to the applications running on top of it. Replicate the workflow of pushing applications to the platform. This tells you quickly if other dev teams may be experiencing an issue with their path to production. Think about cost versus benefit of coverage and complexity. Do you want to replicate every user interaction? Probably not. But you do want to have confidence that your users are happy. So you can also build confidence with fire drills. Why would you even do that? Organizing fire drills or game day is a way to build organizational muscle memory. You don't want to figure out how to access the system or where the password is at 3 in the morning. A way to make this happen is to divide your team in 2 sub-teams for one day. One team is breaking random things on the platform, and the other team is working on getting them fixed. This will also tell you if your system is resilient enough by introducing random failures. Blameless incident retrospective. This is probably the most important of all. It will help you improve over time. What learnings can you take out of an incident? Well, blameless in retrospective are a core to the SRE culture. A blamelessly written postmortem assumes that everyone involved in an incident had good intentions and did the right thing with the information they had at that time. If a culture of finger pointing and shaming individuals or teams for doing the wrong thing prevails, people will not bring issue to light for fear of punishment, and nothing will ever improve. When to trigger an incident retrospective is up to you, but here are some of the reasons why I would do it. The first one would be user visible downtime, or any data loss of any kind. Also, when an on-call engineer needs to do some actions, like release rollback, rerouting traffic, etc. Another reason would be when the time for resolution is above a certain threshold. And the last one, and it's the worst one actually, if there is a monitoring failure, which usually means that you've discovered manually this incident. Not great. You will want to fix that for sure. You've understood. The idea is improvement, reducing downtime, and making the overall system more resilient. So, in summary, talk to each other, and actually never stop talking to each other.
Be curious and start that dialogue. We've given you 4 simple questions to get you started. How are we going to work together? What is your path to production? What level of reliability do our users need? And what are we going to do when things go wrong? We've given you some ideas to get you started, but what are the problems that you experience today, and what's important to you? That will tell you where to begin. And then you want to ask this one final question. Are we getting better at this? There are always opportunities to keep improving and learning from each other. When you go back to the office, start a conversation. You might be surprised what you learn. Thank you, everyone, for coming at the end of the day. I don't know whether we do Q&A. We do have a little bit of time if we want to.
5 minutes. Any questions?
No.
Yeah, one.
For game day, can you talk about how you've seen that done?
So basically what we try to do is with some of our customers which are already mature enough in the practices we've shown you here, usually we try to introduce game day as it's really a game basically. You will want to bring together like your whole team. You will sit them like basically face to face on their desk, and like one team is breaking all the things and one team is fixing all the things. By doing that, basically you can do that like twice a year maybe. When your system grows or when you introduce new people in your team, you will want to try that because it really helps with being faster at fixing your incidents, right?
Yeah, it's really about addressing that fear that we talked about. People don't feel like they can or they should try this stuff, but actually, you actually build confidence in your team's ability to resolve incidents quickly, which means that when a real incident does occur, you're more prepared to deal with it.
Any other questions?
Any other questions? You can come and find us in the hallway, and of course we'll be around all week if you want to have a chat about anything we've talked about.
Thank you.